Yo, yo, yo. Another day. Uh, still struggling. Yes. Okay, let's go. Hopefully my stream is up. Nice. You are given a string num representing a large integer. An integer is good if it meets the following conditions. It is a substring of num with length 3. It consists of only one unique digit. Okay. Return the maximum good integer as a string or an empty string if no such integer exists. Interesting. Interessante. Interesante. Muy interesante. I haven't done today's Duolingo, so I'll do that after this question. No worries. Okay. So I just have to find the longest repeating string which has at least 3 occurrences of the same character. That's all the question is asking, brother. So I can simply say int L, and I have to return that longest string, right? Start from 0. Let's call n as num dot length, right? While L is less than n minus 3, if nums of L is equals nums of L plus 1 and nums of L plus 1 is equals nums of L plus 2 n minus 2. So L can go till n minus 2, right? So if I replace n minus 2 here, n minus 2 plus 2 is n, which is bad, right? No. Sorry. It can go till n minus 4. N minus 4. N minus 4 is less than n minus 3. N minus 2 is greater than n minus 3. So n minus 4, if I replace here, n minus 4 is n minus 2. Should be this. If I place n minus 3 here. Yeah. Now if this is the case, then I have to r equals L while r is less than n and nums of r is equals this is not nums, this is num. Num of L r plus plus, and then at the end max answer index and max len equals 0. Right. So here, if this is the case, then from L to r minus 1, we have a potential answer. So I can simply say if max len is less than r minus L, then we can say that max len equals r minus L and answer index equals L, and we have to move L by L equals R. Else L plus plus. Return answer index is -1 question mark, then empty string. Otherwise, num dot sub str starting from L and max L again. Hopefully this works, man. I kind of raw dogged it. Okay, I messed up, brother. Oh, not L, should be answer index, man. Why is it 777? Have I misread the question? What? Return the maximum good integer as a string or an empty string. What? It is a substring of num with with length 3. It cannot be. Oh. Okay, so we have to modify this section. So I can simply just cast it as int, and I don't even need to do this, brother. Fuck, why don't I read the question first? Why do I assume that is asked? Result equals 0. Let's call -1. So simply this condition is checked, right? We don't need to move R, right? Then I can simply say string current equals this plus this plus this, which is num dot sub str starting from L with size 3. Now I have to cast this string to integer. Okay. String to int C++. S2I. So here I can simply do this even. S2I this. If current is greater than res, then res equals current. And L++ will go every time. Now here res is -1, then an empty string. Otherwise 2 underscore string res. Make sense? Let's see. Okay, it can be 0 0 0. Interessante. Pam 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 para pam pam pam. If is bigger, press if this is greater than res, then I have to keep it as a string, man. I have to keep it as a string, right? So S2I, right? Okay, res equals string current equals, let's not do substring multiple times. Current res equals current, and res should be a string, and let's keep this like this. Ah. Ah, shit. Ah, shit. 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 Do, 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 do. I am also keen to see my last solution. Let's take a look what I did earlier in 2022. Go past leading zeros. Who is drifting in my street, man? Ah, a stack. Okay, yeah, this is also fine, but this is also fine. No problem. So, okay, let's do graph problems again. Congratulations, 100 days badge 2025. Thank you, brother. Generate image. What the fuck is this? Right click to save the image. What? Why do I need to save this image? What? What do you mean? What do you mean, my friend? What do I do with this image? What am I supposed to do? Am I supposed to share this on LinkedIn and like what? That is the most lame shit I've ever seen. Okay, no worries. Let's do graph problems. And I'll just check out who was drifting in my street because I don't want to get yeah, just I'll be right back. Okay, there was no one. It's just my street is flooded, so cars are moving at a fast pace there because they don't want to drown. No worries, man. Couple holding hands. Oh, that's a wholesome question. There are n couples sitting in 2n seats arranged in a row and want to hold hands. The people and seats are represented by an integer array row, where row of I is the ID of the person sitting in the ith seat. The couples are numbered in order, the first couple being 0, 1, the second couple being 2, 3, and so on, with the last couple being 2n minus 2 and 2n minus 1. Return the minimum number of swaps so that every couple is sitting side by side. A swap consists of choosing any two people, then they stand up and switch seats. Okay, that is interesting. Very interesting question. So n is 30, so 2n can be 60. So I think it is a kind of a brute force DFS approach because the constraints are very small. But anyway, let's try to draw so if row is this, basically the point is on 0th seat number 0 is sitting, which is good. On first seat number 2 is sitting, on second seat number 1 is sitting, and on the third seat number 3 is sitting. So first of all, this doesn't have to be, they don't have to sit in their respective positions, they just have to sit to their adjacent elements, right? So adjacent to 3 there should be a 2, and adjacent to 1 there should be a 0. That's all you need, right? Okay, so here I see that the partner of 0 is sitting here, right? Partner of 0 is sitting here, so I can simply switch these guys, right? Or I switch 0, so yeah, if I switch 1 and 2 it will be 0, 1, 2, 3, or if I switch 0 and 3 it will be 3, 2, 1, 0. This is also a valid answer, right? Both are valid because 3 2 are a couple, these two are a couple, right? 3 2 0 1. Yes. So only one switch is needed. Okay. So I have two options here. Maybe I have two options. Either I swap this person or I swap the position of the partner of this person. And by the way, the frame is incorrect. Now it is correct. Okay, so right. Is that all we need to do? Let's take a bigger example. Let's say when n is 3, right? So seats are 0, 1, 2, 3, 4, 5. So I have to fill in 0 to 5 here. Let's say this is 3, this is 1, this is 5, this is 4. What else is left? This is 0, this is 2. Right? How many swaps do I need to get all of the couples together? So I see 3 is here, right? And to the next of it should be what? Okay, let's say any number n is given, right? So if n is odd, then its partner is n minus 1. If n is even, then its partner is n plus 1. This is the simple rule, right? We can figure this out from here. 2 is even, its partner is 3. 1 is odd, its partner is 0. Simple rule. Now I see that n is 3 here. 3 is odd, its partner is n minus 1, which is 2. Now, so I have two options here, right? I see the partner of 3 is not sitting to next to it, right? So what do I do? Either I swap the position of 3 or I swap the position of 2 to here, right? So two options are either I move 3 here or I move 2 here. Which one should I choose? I don't think I have any bias here. I mean, it doesn't seem obvious to me that one can be picked over another. So I have to try both, maybe. So this will be a recursive call. But yeah, I have to copy this array many times. Or should I just do a backtrack? We could do backtrack, because this array can be max of 60 length and I don't know how many swaps are needed. So backtrack seems a good option. So what do I do here? In the first call, I will swap 3 to here. It will be 0, 1, 5, 4, 3, 2. Or I backtrack it again. Another call will be 3, 2, 5, 4, 0, 1. And when I am done with the pair, I simply move by 2, right? Because these are already done. These are done already, right? So I'm thinking of some complex ways, like I don't know, man. I don't think it is that complex. Maybe I'm overthinking. I can write this down and check. Let me just turn off my fan. It's getting... Okay. So I think this approach may work. I can begin writing code for this. Maybe. Let's see. Yeah, fuck it, man. Maybe there's some clever way of finding this out. Why is this a graph question? Because we are doing DFS, right? Okay. Solve row starting from 0. That's it. And swaps, which is 0. Initially nothing is swapped. Int min swap, min swap is equals int max. And in solve I have this starting from n swaps. Now here, what do I need to check? If n and n plus 1 are a couple. If is couple, row of n and row of n plus 1. If it is not a couple, bool is couple. Int a, int b, return absolute difference of a minus b should be 1. If it is 1, then they are a couple, otherwise they are not a couple. If they are not a couple, then there are two options, right? If n equals row dot size, min swap equals min of min swap and swaps. If they are not a couple, I have two options to switch nth person, to swap nth person, or n plus 1th person. Basically, two options are I move 3 to here or I move 2 to here. So for that, I need a map of values, I mean person, to the index where they are located, right? So before that, let's create a map. Since we already know that it is of size n, I can simply create a map here. Map of size n. Initially everything is 0. For int I equals 0, I is less than n, I plus plus. Map of row of I is equals I, right? The value is mapped to the ith index, right? But this map is gonna get copied again? No. Now here's a problem. Should I backtrack? Yeah, I should, man. Pa-pum-pum. Yeah, I think this is a backtrack. But this backtrack call is gonna be very expensive. And then I cannot cache that because backtracking cannot be cached. I think. Should I just raw dog it first and then test? Okay, let's see. When I switch these two, so the values of these two are gonna get swapped, right? Okay, let's pass this, no worries. And we pass in map, and this is passed as a reference. If they are not a couple, move nth person to position of n plus 1 guy. Partner So int p1 equals n, so its partner p2 is get partner of n. Int get partner n, return n mod 2 is equals 0, which means it is even. When it is even, the partner is n plus 1. If it is odd, then partner is n minus 1. Easy. Okay. Move p1 closer to p2. Okay, now there is one more call. I am moving 3 to 2. Now this is obvious, but let's say 2 was here and 4 was here. Now what happens? Partner of 3 is not here, so where should I move to move 3? I can move to here or I can move to here. Which one should I choose? Okay, now obviously if I choose here, then it's impossible, right? I should be choosing now. Okay, now it depends on if the index at which p2 is present. If it is odd, then I should be n minus 1. If it is at even, then n plus 1. Make sense? Makes sense. Right. So index of p1 is just n. Instead of n, let's keep it I, because it is easier to understand. So if row of I plus 1. Right. Move p1 closer to p2. Now what happens here? Int j equals position of p2, right? Position of p2. Now if target will be int get index partner get desired index int I, return if I is odd, if I mod 2 is 1, if it is odd, then I minus 1, else I plus 1. Get desired index, move p1 closer to p2. So what do I need to do? Position of p2 will be t1 get desired index of p2, right? I have to move p1 to t1, right? Then I can simply swap p1 to t1, swap row I and row t1. I think I made this way too complicated already. Swap row I and row t1, and I have to update that map also. So map of p2 becomes t1 and map of row of t1 becomes I. Now the fuck am I doing? Map of P1 becomes T1, and map of row of T1, whatever that value is, should be an I. Row of I and row of T1. Yes. Move P2 closer to P1. Now when this swap is done, solve row. Now I should remain at the same position. I should remain at the same position. Swaps +1 and map. Now I have to undo this, right? Now, okay. Move P2 closer to P1. Now to undo this, I simply copy these three, backtrack, swap them again, and these two guys also. Row of T1 becomes T1, big P1 becomes I. Now if I move P2 closer to P1, get desired index of P1, map of P2 becomes T2, map of row of T2 becomes okay, what the fuck am I doing? Shit. Okay, I messed up already. An index should be passed in here, should be I. Sheesh. This should be J, man. Okay, I'm already confused what I've written here. I should be focusing more on my code design, man, because I go through that very quickly, which is bad. I should have considered my code design in a better way. Now this is way too confusing, man. Fuck. What does get partner do? Isn't these two the same functions? Get partner of P2. Int J is position of P2. Int J is position of P2, which is map. Right. Now if I move P1 closer to P2, so I have to find target T1 for J, and then map of P1 becomes T1, map of whatever was present at T1 becomes I. Lakshya Chabra, how many questions you have solved? Way too many, brother, which I am not proud of. 800, man. Way too many, but this doesn't matter, man. This is useless number. So okay, my alerts are going off. Let me just mute this shit. Okay, move P1 closer. Okay, I have to find the target T1 for J, right? Map P1 becomes T1. Row of T1 becomes I because I'm moving from ith position. Then swap row I and row T1. Row of I and row of T1. Okay. Can you suggest me something? I am in BTech third year and have solved around 120 on LeetCode and 80 on GFG. But my advanced DSA topics are pending like DP, graph trees, so what should be my approach? Your approach should be to study those topics and do question based on those topics. Very simple, man. You have to do hard stuff. I mean, first cover the basics like BFS, DFS, and in DP like memoization and some bottom-up basic questions like I don't know, coin change and stuff like that, and do basic question on trees like level order traversal, in order, post order, and all kinds of traversals on trees, some algorithms on trees, right? So yeah, I have a website which covers basic stuff. Maybe you can follow that. So if you go to the DSA section here, I'll just paste this link right in the chat. You will find all of basic stuff with explanation. I mean, a little bit of explanation. It's not like a 2-page long. It's just summarized stuff. And maybe you can watch YouTube videos that explain those. So if you click, let's say, trees and graphs, you will see all kinds of trees and their definition, what makes them different from each other, and some properties. Segment tree, Fenwick. You can skip these first. You can first simply go through the basics. Yeah, DFS, BFS, their time complexity, topological sort is also basic. Single source, shortest path, Dijkstra's, yeah, all kinds of algorithms. This is advanced, so skip this first. Yeah, this is also important. Yeah. So yeah, just study and do questions. That's the technique. Okay, let's get back here. Move P1 closer to P2. Done. Now backtrack, swap them back again, map them to original things, move P2 closer to P1. Now since I'm moving from even to even, so I already know that T2 is just I plus 1, right? It's just I plus 1. So I don't even need to do this. It's just I plus 1. Then map of P2 becomes T2, and J was map of P2. J is already there. Row of T2 becomes shit. Now I have lost some crucial information here. Okay, thanks for the advice. I am currently following Striver's A to Z DSA sheet. I will surely look your website. Yeah, that's fine. You can look at any DSA sheet and just follow the list of questions. Start from the easiest and then go on higher levels. That's fine. You can follow any DSA sheet, man. There is one neat code, but yeah, just stick to what you are doing. Be consistent. Do questions daily. And yeah, can you also tell me that, like, when I look some questions back, like medium and medium hard, I can't remember the approach, but I have solved those, like the topics I did 2-3 months ago. Just practice, just repetition. You do a question, revisit that like a week after or 2 weeks after, then yeah, it's just repetition. There is no workaround. Also, if you want to remember it correctly, you can make diagrams on a notebook or on just like a board like this, like dry run each and every step. That helps in remembering stuff. So yeah, try to make diagrams and draw stuff out, because writing just code is pointless. If you can't visualize your solution, then it's pointless, man. You have to first visualize the intuition, why are we doing those things that is needed, and then go with the code, because coding is the easiest part in the interview. The first is to come up with a valid solution and like a dry run, a successful dry run that covers all edge cases and stuff like that. So that is more important. Coding is easy. So yeah, my approach is I just draw as many things as I can. So yeah. But yeah, repetition is also important. So yeah. Okay. Yeah, I have made full written notes. Like I look those to revise the question. I have written the full approach there. That's good. Good going. Thank you for the advice, man. Thank you. No worries, man. We are all here to learn. Hope you succeed in life, man. Okay. Let's. Okay. T2 is the position where I need to move P2 closer to P1. So map of P2 becomes T2, and at the end what I have to do is swap row of T2 and the position of the partner, which is J, row of J. I have to do these things. So row of T2 goes to the partner. P2 is initially what? P2 becomes at T2 now. Map of P2, and row of J, whatever was present at Jth position, becomes no. Am I messed up? No, yeah, this should be T2 becomes whatever was present at becomes J, right? And then swap and then backtrack again, right? Backtrack again, and this time I have to move I. This time I have to move I by 2 positions. Do you have a LinkedIn I can connect you on with? Yes, I have a LinkedIn. Let me just send that in the chat. I'm not a big timer, like I'm not in Fang, but yeah, it's all right, man. Okay. Yeah, this is my LinkedIn. Feel free to send a message, or if you want a referral request, I'll be happy to help. Yeah, man. I don't open LinkedIn often because it's just way too many AI generated posts in the feed. I just look at jobs and I don't know, connection requests. Yeah, I have many messages to catch up on here. Many people are asking for referral, so I should probably do that. Okay. Yeah, I will check out, man. I will check out. Okay, when I solve this, now backtrack, right? Backtrack is simply this. This becomes at the top. Else solve this. I don't know. I think this will go out of time limit. I'm pretty sure non-void function does not return. Okay. My brother, my bad. Min swaps. Is it min swap or min swaps? Min swap. Singular. Min swap equals minimum. Okay. Nice. Let's run this shit. Okay. Is couple row I plus 1? Interessante. What? 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 Okay, 0, 1, 2, 3. Okay, 4. Oh, I have to return from here, man. Damn. Okay, no, I just needed your LinkedIn in case I need some advice, as I am from a tier 3 college. Same here, man. Same, I'm also from tier 3. So we are in the same boat. Okay, this works. Surprisingly, this is working. Let's run on the real test cases. I hope I just know that this will fail. 100%. Things never work on the first try. Yes, I knew that. Okay, so what was my answer? Expected 4, but my answer is 3. Shit. Something wrong is happening. Let's take a look at some hints maybe. Say there are n 2-seat couches. For each couple, draw an edge from the couch of one partner to the couch of the other partner. Draw an edge from the couch of one partner to the couch of the other partner. What the fuck does that mean? Say there are n 2-seat couches for each couple. For each couple, draw an edge from the couch of one partner to the couch of the other partner. Okay. Then what okay. What the fuck? Maybe I should look at the final solution, man, because this is getting let's take a look. Fuck this. Using cyclic swapping. Java union find, easy to understand. Let's see how union find is working. Think about each couple as a vertex in the graph. So if there are n couples, there are n vertices. Now if in position 2i and 2i plus 1, there are person from couple u and couple v sitting there. That means that the permutations are going to involve u and v. Yes. So we add an edge to connect u and v. The minimum number of swaps, n minus number of connected components. This follows directly from the theory of permutation. Any permutation can be decomposed. It took me some time to understand, but I think I understand it now. I am adding my explanation for others who are having issues in understanding. Let me know. We need n nodes or connected components, n couples in our final result. Let's say currently there are k connected components. Each component is a cyclic permutation. Let's assume there are n1 nodes in C1 component and n2 nodes in C2 component, and so on. Total number of nodes to resolve one connected component with d nodes will take d minus 1 swaps. Yes. So to resolve C1 will n1 minus 1, n2 minus 1, and k minus 1. Total swaps. N minus k. I think this is not easy to understand. Let's see this. Okay. You may have encountered problems that can be solved using cyclic swapping before, like LC41 and 268. Have I solved these two questions? Let's see. I haven't. Hard and hard. Oh, easy. In this post, I will use simplified n integers problems to illustrate the cyclic swapping idea and then generalize it to this n couples problem. Assume we have an integer array row of length n which contains integers from 0 up to n minus 1 but in random order. You are free to choose any two numbers and swap them. What is the minimum number of swaps needed so that we have I equals row of I? First, to apply the cyclic swapping algorithm, we need to divide the n indices into mutually exclusive index groups, where indices in each group form a cycle. Here we employ the notation to indicate that we expect the element at index I to appear at index j at the end of the swapping process. Before we dive into the procedure for building the index groups, here is a simple example to illustrate the ideas, assuming we have the following integer array and corresponding indices. Okay, 2, 3, 1, 0, 5, 4. Starting from index 0, what is the index that the element at index 0 is expected to appear? It should appear at 2. The answer is row of 0, which is 2. Using the above notation, we have 0 to 2. Then starting from index 2, what is the index that the element at index 2? Oh, the answer will be row 2, which is 1. So we have 2 to 1. We can continue in this fashion until the indices form a cycle. Yes, makes sense. Which indicates an index group has been found. Then we choose another start index that has not been visited and repeat what we just did. This time we found another group, after which all indices are visited, so we conclude there are 2 index groups. And then we just count the number of arrows. Is that what we are supposed to do? Now for an arbitrary integer array, we can take similar approaches to build the index groups. Starting from some unvisited index I0, we compute the index I1 at which the element I0 is expected to appear. In this case, I1 it becomes row I0. We then continue from index I1 and compute the index I2 at which element at I1 is expected. Makes sense, man. Yeah, the union find can solve this very easily. Okay, my buddy is calling for a gym. Yeah, I should probably go. Yes, I have a meeting at 6:30, but I will go there, no worries. Yes. Cool. Eventually, the list will repeat itself. It will repeat itself from index I0, not other proof of implication. Base case. If we have a group of size 1, what is the minimum number of swaps needed to resolve the group? Yeah, res. Yep. Okay. N couples problem. Except now we have different placement requirements. Instead of this, we require I equals ptn what where we have defined 2 additional arrays, ptn and pos. Ptn. I get the idea, and I will work on this offline because yeah, this is a good challenge. This is a good challenge. Right, 765. All right, I need to solve this question. What are the topics, my friend? DFSB. This was a context question, which is good. Contest. Nice. Okay, so I will solve this question offline. I need to go to the gym right now, so I will catch you guys tomorrow probably. Tomorrow is Independence Day. Yes, independence, but we are enslaved by leetcode. Let's go. All right, so I'll see you guys tomorrow, and have a good rest of the day, man. All right.